Hi everyone, so today we're going to do lesson 7.3, solving systems with multivariables. So we will be looking at solving a system with X, Y, and Z. So let's get started. So once we are in triangular form, we can solve any system. So triangular form, I like to think of it as we have one equation in one variable, z, one equation in two variables, y and z, and one equation in three variables, x, y, and z. When you have this triangular form, then you can use back substitution to solve. So let's go ahead and we're going to start with z. We are going to plug z into the second equation. So we have y subtract 2. We will plug in 3, which is z, equals -7. Y subtract 6 equals -7. Add the 6 over, and we have just solved for y. So y is equal to -1. The next thing we're going to do then is figure out what x is. So we will take the second equation, or sorry, the first equation, and that's a little crooked, and we have x subtract 2y, and y is -1. So we're going to put in the -1, subtract 2, and we're going to put in the z, which is a 3, and that's equal to 7. So now we have x plus 2 subtract 6 equals 7. X subtract 4 equals 7. Add the 4, and x is going to equal 11. When we write our answer, we write it as an ordered triple. So we'll write it as x, and then y, and then z. And this is actually, if you were to graph it, you graph it on a third-dimensional plane. So you graph x and y, and then you come out into space to graph z. Example number 2, we have a system of 3 equations in 3 variables, and we want to solve for x, y, and z. The first thing I like to do is I number my equations. So this is equation 1, and this one's equation 2, and this one's equation 3. Now we're going to pick any 2 equations, we're going to line them up and eliminate a variable. So you have lots of choices. I think I'm just going to pick equation number 1, which is 2x plus y subtract z equals 0. And equation number 2, which is x subtract y plus 2z equals -3. And I'm going to use elimination. I'm going to add these 2 equations together, and I want you to know that positive y and negative y is going to cancel. So 2x plus 1x is 3x, and -z plus 2z is plus z equals -3. So I just eliminated y. Now you're going to come up to equation 1 and 2, and you're going to cross off one of these original equations, and you're going to replace it with the new equation. And you do this so you only are always working with 3 equations. Now, if you eliminate variable y, you want to eliminate variable y again. So I'm going to take equation number 1, which is 2x plus y subtract z equals 0. And I'm going to take equation number 3, which is negative x plus 2y subtract 3z equals 7. And we're going to eliminate the same variable, y. And so if I'm going to get rid of y, this top equation is going to have to be multiplied by a negative 2. I will write this out to the side as negative 4x subtract 2y plus 2z is equal to 0, and negative x plus 2y subtract 3z equals 7. Notice I recopied the second equation so that the two equations line up. If you make one mistake, the whole thing's going to be wrong. So just by taking time to rewrite those equations is going to save you from a headache in the long run. So you can see that my y's canceled. So now I have negative 5x subtract z is equal to 7. I am going to either replace equation 1 or 3. I'll go ahead and just cross off 3, and I'm going to replace it with negative 5x subtract z equals 7. Now I'm going to line up equation 2, and I'll come down here. So equation number 2 is 3x plus z equals negative 3, and equation 3 is negative 5x, oh, that's an x, erase. Okay, back to negative 5x subtract z is equal to 7. And this turned out just great because now my z's cancel. And if they didn't, then I would have to multiply the equation by something to get them to cancel. And I'm left with negative 2x is equal to 4. Divide by negative 2. And x is equal to negative 2. So now, because I used equation 2 and 3, I'm going to cross off either 2 or 3. And I'm just going to cross off 3. And I'm going to replace it with what x equals. So x is equal to negative 2. From here, you can see I have a triangular problem. X is 2. I have 1 in 1 variable, 1 equation in 2 variables, and 1 equation in 3 variables. So I'm going to take negative 2 and plug it into equation 2. So 3 times negative 2 plus z equals negative 3. Negative 6 plus z is equal to negative 3. Add the 6, and z is equal to 3. So I'm going to cross off equation 2 and write z is equal to 3. And then the last thing I'm going to do is take equation 1, and I'm going to plug in x and z. So I have 2 times negative 2 plus y, I don't know what y is, subtract, and then plug in the 3 for z, is equal to 0. Negative 4 plus y subtract 3 is equal to 0. Negative 7 plus y is equal to 0, so y is equal to positive 7. So now I'll cross off equation 1, and I'll write y is equal to 7. So my ordered triple is negative 2, 3, and 7, and now I'm done with example number 2. Example 3, I lined up equation 1 and 2, as you can see, and I've decided that I want to eliminate x's. So I'm going to multiply the first equation by negative 3. When I do that, I get negative 3x plus 6y subtract 3z is equal to negative 12. On the bottom, I have 3x subtract 6y plus 3z is equal to 7. Now you can see we have a problem here because x's cancel, y's cancel, and z's cancel. So 0 is on the left-hand side of the equation. On the right-hand side of the equation, when you add the two equations together, you get negative 5. Because this is not true, my solution to the system is no solution for example number 3. So that's everything for today's lesson. Thanks, guys. Have a fabulous day, and we will see you soon.